Greetings, friends. Welcome to Deep Nature Secrets. Today we will learn about the spectacular star-nosed mole, an alien strange creature. Let's start. The star-nosed mole's nose isn't just a questionable aesthetic choice, it is the most sensitive tactile system among all known mammals. Although it resembles a small octopus stuck to the animal's face, those 22 tentacles are actually extensions of the snout's skin. Contrary to what the name suggests, it doesn't use this star for smelling, but rather to feel the world with a precision that would make any laser scanner envious. The magic happens at a microscopic level. The surface of these tentacles is coated with more than 25,000 sensory receptors called ima's organs. To give you an idea of the density, imagine that every square millimeter of this skin is a keyboard with thousands of keys sending simultaneous signals to the brain. In laboratory tests, scientists observed that the mole can touch something and decide whether it is edible or not in just 8 milliseconds. For context, your brain takes about 650 milliseconds just to process that a traffic light has turned green. Basically, it lives in real time while the rest of the world moves in slow motion. The tactile fovea, much like our eyes, have a central area of sharp vision, the fovea. The mole uses tentacle pair number 11, the two lower central ones, as its primary focal point. It scans the terrain with the other 20 and, as soon as it senses something interesting, it gives a final touch with pair 11 to confirm the prey's texture and size. Neurobiology studies show that the cortical representation of this nose in the mole's brain is gargantuan. Nearly half of the somatosensory cortex, the part that processes touch, is dedicated exclusively to those few centimeters of nose. It is as if its body map were 10% body and 90% snout. This allows it to be the fastest predator on Earth. In documented experiments, it was able to find, identify, and swallow an earthworm in just 120 milliseconds, or 0.12 seconds. It is so fast that if you blink during its dinner, you will think the food simply teleported into the animal's stomach. If you were an earthworm living in a damp swamp, the star-nosed mole would be the villain of a slasher horror movie. Imagine a blind monster that, on an earthworm scale, runs at 80 km per hour through dark tunnels and possesses a giant hand on its face that moves so fast you don't even feel the touch before becoming protein. While we humans need flashlights, night vision goggles, and GPS to navigate in the dark, the mole only needs to say hello to the ground with its nose to know exactly where the exit is, where the snack is, and probably where you left your lost keys in the garden. It is the ultimate proof that, in nature, being cute is optional, but being efficient is mandatory. If you've made it this far, thank you for watching. If you'd like to support me in producing these videos, please like, subscribe, and keep watching. The star-nosed mole's habitat is very different from other moles that seek dry soils. Condylera cristata chooses to live on the boundary between land and water. It inhabits humid areas, such as swamps and stream banks in eastern North America. Its network of tunnels is a functional piece of engineering. The galleries are dug directly into the muddy soil, and many have hidden exits below the waterline. This allows it to dive into rivers and lakes without ever needing to surface, protecting itself from predators while searching for food at the bottom of streams. Because the environment where it lives is dark and murky, vision becomes secondary. It uses the soil moisture to its advantage, as water facilitates the perception of movement and textures through its sensory nose. Its wide, strong front paws function both for digging in dense mud and as efficient paddles for swimming. By mastering this difficult terrain, it is able to access food sources, such as small crustaceans and aquatic insects, which are out of reach of purely terrestrial animals. Elsewhere, the processing and reaction speed of the star-nosed mole establishes it as the fastest predator on Earth. While most hunters in the animal kingdom need time to identify, pursue, and finally attack, this small mammal completes the entire hunting cycle in a fraction of a second, completing the sequence of touching its tentacles to prey, confirming its edible nature, and swallowing it in just 250 milliseconds. This absurd performance is supported by an ultra-fast identification phase, where the brain takes a mere 8 milliseconds to decide whether the object touched is food or debris. During its frantic ground scan, the mole uses its 20 outer tentacles for spatial location, but reserves the lower central pair number 11, for the coup de grace. This pair functions as the sensory focus, providing definitive tactile confirmation before ingestion. This extreme speed is not a mere evolutionary quirk, but a metabolic necessity, since the animal expends enormous amounts of energy digging through dense soil and swimming in icy waters, needing to consume prey at an industrial rate to survive. For the human observer, the scene is a blur impossible to follow with the naked eye. We live in a world where visual reaction takes almost a second, while the mole operates on a timescale where reality seems frozen, allowing it to process and act on the environment with lethal efficiency. At this stage, we must explore the underwater capabilities of the star-nosed mole, which proves to be an efficient predator in environments where ordinary terrestrial olfaction would completely fail. As a semi-aquatic animal of excellence, it uses its wide, powerful front paws like paddles to navigate agilely through the beds of streams and lakes. The greatest biological difference of this species is its rare ability to smell underwater. The mole blows small bubbles of air against objects or chemical trails and quickly re-inhales them, capturing odor particles that allow it to track prey even submerged. This adaptation allows it to exploit resources such as small crustaceans and aquatic insects, maintaining its sensory advantage in a hostile environment. By connecting its terrestrial tunnels directly to the riverbed, it moves between the two worlds with a fluidity that protects it from external threats while dominating a hunting niche inaccessible to any other mole species. In this conclusion, we will examine the external anatomy of the star-nosed mole, a classic example of function-dictating form. Its body has a fusiform and aerodynamic shape, designed to reduce friction both in narrow tunnels and underwater. Its fur is dense, short, and extremely water-repellent, allowing the animal to maintain an insulating layer of air next to its skin, essential for thermoregulation in humid and cold environments. Furthermore, the robustness of its forelimbs is not only for swimming. The bones are short and the pectoral muscles are massive, allowing the claws to function as mechanical excavators capable of removing saturated and heavy soil with minimal effort. At a deep biological level, the animal operates with an internal engine room adapted to low oxygen conditions. Living in deep tunnels and waterlogged soils, it faces high levels of carbon dioxide. Its survival is ensured by a specialized hemoglobin, with a superior affinity for oxygen, and high concentrations of myoglobin in the muscles, which act as reserve tanks for prolonged dives or intense digging. When submerged, it can reduce its heart rate to conserve energy, prioritizing blood flow to the brain and its sensory nose. Our video is almost over, but here are some interesting facts about this amazing mole. Did you know that, unlike other mammals, the star-nosed mole does not hibernate, but remains active year-round, being able to escape through the snow and hunt in frozen waters under layers of ice? Regarding vision, the star-nosed mole has tiny eyes hidden by its fur, making sight a secondary and almost non-existent sense. It relies almost entirely on touch with its nose to orient itself in the dark. If you imagined an obese mole with an alien nose and a large belly, you're mistaken. It has a long tail that thickens in the fall, functioning as a strategic fat reserve to provide energy during periods of food scarcity. Even its habitat gives it an advantage. By inhabiting swamps and waterlogged soils, it rarely comes into contact with humans, which passively protects its species from interference and the controls common to garden moles. Our video has now definitively ended. Thank you for taking some of your time to learn a little with me. If you want more content like this, subscribe and leave a like. Until next time.